Hello. As is normally the case, there's generally more than one way to do the same thing. The thing I'm going to show you right now is passing data into a program or a script or something like that. Now, the two ways I'm going to show you are pipelines and redirection. Now, oftentimes you'll see both of them being used in different cases and wonder, well, what's the difference? Are they just the same thing? But they are actually subtly different. So let's have a look. So say we want to take the output of X, R and R. There you go. Shows you all the display information. And I just want to list the ones that are currently connected. So I can take that output and pipe it using a pipeline to grep, and I can look for space connected. Now I say space connected because if I just search for connected, it's also going to match on disconnected. So let's say we're going to match on space connected. And we run that, and there you go, there are the two displays that are connected, EDP1 and DP3. There's my internal laptop display and the HDMI port. But on the graphics card it's identified as a display port, so evidently that's being converted internally to the laptop. So that's cool, that works. But what's the other way of doing it? In fact, let's just adjust the screen size. There we go. But what's the other way of doing it? Because you said there were two ways, right? Well, another way of doing it might be to say grep connected, and I want to input the output of this command. There you go, that did exactly the same thing. Now in the case of grep, there is actually a third way that we could do it, and it's basically the same, except we take that off. Great, so those all do exactly the same thing, so it doesn't really matter which one you pick, right? Well, they have exactly the same outcome, but they do it in different ways. There are essentially two things happening here. The first is using a pipeline, and that's this. And the second is using a redirection, which is this. The third, it doesn't use a redirection, but it does just use a command substitution, but in this case it uses a file command substitution. So in this instance, we're essentially giving grep a file and saying please search for the word connected in this file. And in place of a file, we've got XR and R as a stand-in. Now we can see that if we just say echo XR and R. There you go, that's what this comes out as. Dev FD63, file descriptor. And it seems to always start at 63. I'm not sure why. If you know why, please let me know. I'd be interested. But that's it. This is the file that we're getting. Now this file doesn't exist now. If I say ls show me this file, it doesn't exist. It only existed for the lifetime of this command, echo output the path, and then that was it. That was the end of it. Now this file is actually a pipe. So as this command is outputting on its standard out, that is getting put into this pipe, which in this case, that pipe is then being read by grep as if it were a file, because pipes are just files that you can read from. So this is using grep to do everything itself and saying, here I'm going to give you as the first argument something to search for, and as a second argument a file in which to search for the first argument. In this case, what we're doing is we're saying to grep, please search for this. And if we just run that, grep connected, you'll see that it just hangs. Now it hasn't crashed, but it's waiting for us to give it some input. So I am connected to greps standard in. And there you go. It found it. I am disconnected from spelling, apparently. And it didn't find that. So in this case, we've said to grep, please search for space connected. And it's gone, okay, well, you haven't given me a file to search in, so I'm just going to search in standard in. And in this case, because we're not doing any, it's not part of a pipeline, and it's not got any redirection. So no pipeline, no redirection. So grep's standard in stays connected to our terminal. And we can quit out of that, and that's all done with. Oh no, what's that? Go away. Okay. So I've just lost everything I was looking at now, haven't I? That was clever. There we go. Let's just bring these back. That one and that one. Okay. So that's what's going on here. Sorry, not on this one. On this one, and on this one, because we're only giving grep one argument, right? Grep one argument. Grep one argument. So what exactly is the difference between this and this? Well, you know, the obvious answer is this one has a second arrow thingy, angle bracket, less than symbol. And what that symbol means is whatever is in this file that comes after it, please pass this into grep. So, for example, we could say grep processor, and then pipe into it. Well, forgive me, we're not going to pipe into it, we're going to redirect into grep proc CPU info. And this is a file. So if we say type proc CPU info, oh, of course. Oh. Okay, well, whatever. It's a file. Let's have a look in proc. There you go. Where are you? Where are you? Oh, there, you're right there. There you go. See? Proc CPU info. So we've taken the contents of this file and we've put it into standard in here. Now, this may seem a little bit odd and counterintuitive because it's kind of going backwards, right? I mean, because another way of doing that would be to say cat proc CPU info and then pipe to grep processor. And that did the same thing. So what was the difference between those two? Other than one is backwards and therefore ridiculous. Why would you do it that way? Well, and this is where the subtlety comes in and where a lot of people get confused with while loops, is that pipelines run in a subshell, but redirections don't. This is simply a command that has had something redirected into its standard input, whereas this is a pipeline of commands, and it creates a subshell for that to execute in, because we're going to be feeding, connecting things together and doing all manner of stuff. So these happen in subshells and are isolated from the calling shell environment. So do we recognise any of this? I mean, would it look more familiar to you if perhaps we did this? So now we're using a pipeline, and its output is being redirected, exactly the same, to a file. And if we cat temp grep out, there it is. So this is actually exactly the same as that. It's just the other way around. And the thing that seems slightly unintuitive about it, I guess, is that you're feeding in something from the right, as opposed to going down the pipeline like this, to the right, from the left to the right. Now, this is why you'll often see things like this. While read number, do echo number, done, redirect, and then a command. So we could do exactly the same thing and get the same result if we said sequence 10 and pipe that to while read number, do echo number, done. Exactly the same result. Okay, but so again, what's, you know, this seems nicer, right? Because I mean, in most languages, that's the way around it would go. You'd have your thing at the top, and then you'd loop round it. But in this case, we're doing it this way round. Why do people seem to do this then, instead of doing this? Because this, certainly to me, seems to be more common if you're looking around on Stack Overflow, places like that. You'll see this pattern a lot more than you'll see this pattern. Well, I can demonstrate why that's the case. So if we say declare last num is 0, echo last num. There we go. Now if we say while read num, do last num equals num, done seek 10. Okay, echo last num 10, like we'd expect, right? So with every iteration, we're overwriting last num with the value that we got out of seek. So it's going to set last num to 1, 2, 3, 4, so on and so on, until it gets to 10, and then the loop has ended, and we're on the next command afterwards, and last num has the value 10. Okay, cool, straightforward. You know, this is fairly simple. Okay, don't get it. What? So why? You know, why do that's just standard loop behavior, right? You've defined a variable outside of the loop, you're updating it inside the loop, and then after the loop, it's got the last value that it had inside the loop, right? This is fairly standard in most languages, certainly, well, every language that I know of, or have played with rather. What is so special about this? Well, if we do it the other way, seek 10. Oh, sorry. Before we do that, let's unset last num. Echo last num. There we go. It doesn't exist anymore. So declare last num equals 0. Echo last num. It's 0. Excellent. Seek 10, and then pipe that into, because we want to iterate over this output, right? This seems perfectly sensible and straightforward and readable. While read num, do last num equals num. Done. Cool. And if we echo last num, just like in the previous case, we get, oh, Huh. What happened? Did the loop not run? Echo num. No, the loop's definitely running. Last num? Last num's being updated. So how come last num is 0 here? Well, this is a pipeline. And pipelines run in a subshell. And subshells are spawned with an exact copy of the environment of the parent shell. So it will have a copy of last num 0 in it. And every time it iterates, it increments last num. Fine, not a problem. Then the pipeline finishes. It's done. We're all over with. It exits the pipeline. The subshell that it ran in is destroyed. And subsequently, any of the changes that it made to its environment are lost, because those changes were made to the subshell's environment, not to the parent shell's environment. As a further demonstration of this, we can simply say, okay, echo last num is 0. Fine. Last num equals 1. Echo last num. It's 1. Fine. Echo foo pipe 2 last num equals 2. Now this doesn't make a great deal of sense because last num equals 2. This variable declaration is not going to use any standard in. But yeah, bear with me. Run that. Echo last num. It's still 1. Again, this happened in a subshell. This shell's environment was not modified. It remains unaffected. And this is one of the forms of scoping that shell scripts have. So here is some of the confusion that comes about when people say that all variables in Bash are environment variables, or if you want to make sure that a variable gets through to a subshell or something like that, or another command that you're about to execute, you have to make it an environment variable. And, well, yeah, that will work, but it's a bit overkill, really. It's, I don't know, I suppose like trying to tap in a picture hook using a pneumatic jackhammer. It will work. It has the potential to cause a lot of damage along the way, but yeah, it'll work fine. But this is because of the lack of understanding of this very subtle behavior, basically. So if I say, again, another demonstration, if I say last num, well, we've already shown that if I just say last num equals, it'll change it. But if I put this into a subshell, last num equals 2, and run that, cool, that ran. But echo last num, it's still only 1. So there you go. Pipelines run in subshells. So if you see anything that looks a little bit like this in a shell script, where you're piping to a while read loop, and you're wondering why variables that you're setting are not persisting beyond the loop, this is why. It's not that the body of a while loop happens in a subshell. It's an oversimplification, because the body of a while loop only happens in a subshell if it's in a pipeline. So how about this? How about we say while read num do, okay? So let's set it to 1. There you go. Let's set it to 2, 3, 4. Excellent. Quit out of that, and now let's have a look at the value of last num. It's 4. The body of a while loop does not execute inside a subshell. A pipeline executes inside a subshell. So, there you go. I hope that was useful. I hope that was informative. I'm up to 20 minutes, so that seems like a good point to kill the video. So, yeah, please let me know if there's anything else that I can try and explain or demonstrate. And I'll happily give it a go if I can. Well, if I can understand it myself to the point at which I feel comfortable describing it. So, yeah, there you go. Pipelines and redirects and subshells. Cheerio.